Hey guys, Doctora Mom turns online professor because of coronavirus. Here we go again, except now we're in Lucas's bedroom. That's why you see wild and free. His wall happens to be really good space, so hey, he let us borrow it once again. Thanks, Lucas. So the one-way ANOVA, if you saw my previous videos and you were looking at the independent t-test, then you're going to start to see that this is very similar to the independent t-test. The t-test had the disadvantage that it could only look at two actual variables. The ANOVA allows you to look at two or more. So let's look at that real quick. If we were looking at something like religion, and in religion we wanted to use something like, let's say, Catholic, Jewish, and Muslim. And these three we wanted to make a comparison. If we were going to do a t-test that only limits you to doing two, you would have to make a comparison of how many tests? Catholic to Jewish, Jewish to Muslim, Catholic to Muslim. That's the only way you could compare them, by running essentially three tests. And every time we ran the test, we talked about in previous videos the idea of doing a type 1 error. Basically, not making your test strict enough, and then you're going to end up having a huge margin of error. And are you going to keep the level of accuracy that you wanted to? So think about it. If your alpha level was set at 0.05, you are 95% sure of the results that you got. You have a 5% margin error of window, a 5% chance of being significantly different than everything else, and 95% was your norm. You wanted to keep at that level of 95%. Every time you ran a t-test, Catholic to Jewish, you lost 5%. Jewish to Muslim, you lost another 5%. Catholic to Muslim, you lost another 5%. A total of 15%. Every single time you ran a test, these three tests, your test-wise alpha, in other words, the alpha of the test was supposed to stay at 95%. But every time you ran it, you lost the percentage. So if you want to make this comparison of three, you're only at 85% level of accuracy. That's a problem because you need to stay at 95. Because the t-test, the independent t-test that looks at two different groups compared to each other, where they're independent of each other, you can't be measuring either one of the groups, you have to be one or the other, end up giving you this problem. So what you wanted to do was called your experiment-wise alpha. Your experiment-wise alpha was the lowest amount that you could lose in terms of testing. So when you were testing, you wanted to make sure that your entire experiment, the whole model, stayed at this 5%, at this 95% level of accuracy. But when you ran three different t-tests to compare these three different religions, you lost 5 every single time you did it. So in other words, you realize I can't run t-tests to compare more than two groups. I have to now move on to another test. And that is the advantage that we have when we can actually run the ANOVA. The one-way ANOVA is going to do one very specific thing for us. The one-way ANOVA is going to allow us then to run all three of these at the same time. So once again, if we look at religion, right, we're going to look at Catholic, Jewish, and Muslim, right, to abbreviate a second. We're going to look at them, but we can do all three of them at the same time. In other words, we can stay at that 5%, or we can stay at that 95% level of accuracy because this was the alpha level that we chose. And so this allows us and gives us a huge advantage. But we have to keep in mind, to run this test like any other test, you have to keep in mind that you go with all the assumptions or the criteria or requirements to be able to actually run this test. So that's what we're going to talk about. Now that we understand the advantage as to what the ANOVA allows us to, specifically the one-way ANOVA, let's now talk about the 6 assumptions that we're going to do with each of these and understanding the advantage it has over the independent t-test.